Hello everyone and welcome to the new unit, which is chapter 18, which is all about fractions, indices and standard form. Okay, for the first part of this lesson we're going to be looking at fractions, and if you could please start by having a look at the recap activity that's on the screen. Have a go, do your best. We will go through the solutions, but we will be going through a lot of this as we go throughout the module, so don't worry if you don't remember any of it from your past studies. We will go through it again, so just do your best please, pause the video and play when you're ready to go through the solutions. I'm just waiting for my visualizer to load and we'll go through the solutions. Okay, so the first question, the first section of questions, we're dealing with negative numbers, okay? So for 1A, you have been asked to multiply -2 by 3, positive 3, okay? So what I like to do with these kinds of questions, if you ignore the signs for the moment and just do 2 times 3, I know that 2 times 3 is 6. But now I need to consider my signs. I've got a minus multiplied by a positive, and a minus and a positive make a minus. If the signs are different, you're always going to end up with a minus answer, okay? So your answer there should be -6. For B, we have -2, and I'm taking away another 3. So I'm at -2 on my number line, and I'm taking away another 3 from that. So I'm going to continue going to the left, okay? Maybe I'll do a quick number line just to demonstrate that. So I'm up -2 here. That's -1, 0, and 1. And this is going to continue going down at -3, -4, -5, -6, and so on, okay? So you're currently at -2. If I were going to add 3, I would be going this way. That's if you add. But when you subtract, you need to go in the opposite direction, okay? I'm minusing a positive 3, so I'm taking away another 3 from -2. So I'm here and I'm going to take away 3. So 1, 2, 3 gets me to -5. So your answer here is -5. Okay, for C, so you've got to remember the rules now. We have 5 minus -3. When you see two minuses directly next to each other like that, they become a plus. So actually you're doing 5 plus 3, and that's 8. And then finally, for part D on question 1, you've got -7 plus -4. Okay, so I have -7 plus -4. Okay, that's essentially -7 minus 4. So that's similar to B. I start at -7 on my number line and I'm minusing another 4 from it. Okay, so -7 plus -4 is going to be -11. And that's your answer there. Okay, so that's question 1. I would hope that everyone could have had a good go at those ones. Let's go to question 2. So for question 2, it asks you to write these decimals as fractions. Okay, so for 2A, we've got 0.1, and 0.1 is 1/10. For part B, we have 0.01, so that's 1 over 100, 100th. And for part C, we've got 0.001, and that's 1,000, 1 over 1,000. Okay? If you struggle with those, I like to try and think of the place value table. So if you were thinking about your place value and your columns, that's your decimal. There's your ones, tens, hundreds, and so on. They're all positive. And going down, you've got your 0.1s, your 0.01s, your 0.001s, which are your 1/10, 1/100th, 1,000th. Okay? So you can use that to help you. Let's have a look at question 3 now. We've got 3A. And we are doing 0.9 multiplied by 10,000. Okay, 0.9 multiplied by 10,000. We are making 0.9 10,000 times bigger. Okay, there's 1, 2, 3, 4 noughts there. Okay, so we need to move this to the right by that many number of places. Okay, so if I'm going to write 0.9 down here, and I'm going to say 1, 2, 3, 4, and in each of those gaps you're going to have a naught, and that naught's going. Okay, so your answer would be 9,000. Okay, 9,000. You've moved your decimal place 4 places to the right. Okay, and 3B, you've got 1,000 multiplied by 0.705. So we're making 0.705 1,000 times bigger. So I need to move my decimal 3 places to the right this time. So I'm starting here and I'm going 1, 2, 3. My decimal would end up at the end of the 0.705, and that will end up giving me 705. Okay, because that is 1,000 times bigger than 0.705. For A, you've been asked to work out 36 divided by 10. So we're dividing by 10, so we're making 36 10 times smaller. So if you look at 36 over here, you imagine your decimal at the end, we're making it 10 times smaller, so we're moving the decimal 1 place to the left, and that will give me 3.6. Okay, for B, we have 0.81 divided by 1,000. Okay, it's the same as before. I'm going to write 0.81 over here. We're making 0.81 1,000 times smaller, which means we need to move our decimal 3 places to the left. So we start here, it's going to go 1, 2, 3, and that's where my decimal will end up. So you need to fill out with the noughts, and you're going to end up with 0.00081. Okay, because it's become 1,000 times smaller. It's important that you remember that when you've moved it, that's where the decimal belongs, and as it's less than 0, you're going to need a 0 in front. Okay, so 5. For 5A, we're simplifying. Let me just move this up 1 second. For question 5, we are simplifying some fractions. We've got 3/15 to simplify. Okay? Both numbers are divisible by 3, so I'm going to divide them both by 3. 3 divided by 3 is 1, and 15 divided by 3 is 5. So you should have 1/5 for 5A. For 5B, we've got 10/25. Okay, they're both divisible by 5. 5 goes into 10 twice, and 5 goes into 25 5 times. And you can see you can't simplify that any further. And for part C, we have got 8/20. Okay, they're both divisible by 4. if you couldn't see that, you could start by dividing by 2. So I'll do that first, divide by 2. If I divide them both by 2, 8 divided by 2 is 4, 20 divided by 2 is 10. They're still even, so I know they're still divisible by 2. 4 divided by 2 is 2, 10 divided by 2 is 5, 2/5, and that's as simple as they go. If you could see they were both divisible by 4, you'd just say 8 divided by 4 is 2, and 20 divided by 4 is 5, and you got straight to the 2/5 there. Doesn't matter which way, as long as you leave your answer in its simplest form. Okay? Question 6. Now these are the bits that I'm thinking maybe you couldn't remember as well. Is asking you to write 19/5 as a mixed number. Okay? Currently it's improper, and it's improper because the numerator is bigger than the denominator. So it's asked me to write it as a mixed number, and a mixed number means there's going to be a whole number and a fraction together. And to do that, I start by saying, well, how many 5s go into 19? Well, 5, 10, 15, 3 5s go into 19. So I'll write 3 as my integer. And then how many are remaining from 15 to 19? Well, 4 are remaining. And then your 5 stays the same, okay? So it's 3 whole lots of 5 go into 19 with 4 remaining. So your integer is your whole number, and your numerator there from the fraction is your remainder. So it's 3 and 4/5. Number 7 has asked you to write 4 and 2/3. So this is a mixed number now, and it wants it as an improper fraction. And improper fraction, like I said, means that my numerator is going to be bigger than my denominator. And to do that, I need to do 4 multiplied by 3. That gives me 12. Add 2. That gives me 14. That's my numerator. And my denominator stays as 3. So it's 14/3. 14 over 3 as your answer. Okay? Moving on. We have... Now we're multiplying fractions, okay? We will be covering this in today's session, so don't worry if you didn't get this, okay? If you didn't remember how to do it, we're going to cover it today. So we've got a half multiplied by 3/5. When you're multiplying fractions, it's quite a simple one. You just have to remember what the rule is. All you do, multiply the numerators together, so the 2 top numbers, and multiply the denominators together, so the 2 bottom numbers. 1 times 3 is 3. 2 times 5 is 10. Your answer is 3/10. Okay? The next one, part B, you've got 3/7 multiplied by 2/9. Same again. 3 times 2 is 6. 7 times 9 is 63. And there's your answer. Next one, question 9. We are dividing fractions. Again, we're going to go through this in today's lesson, so don't worry if you're unsure. We have a quarter divided by 2/3. And the rule when you're dividing fractions, you keep your first fraction the same. So I keep 1/4. You change your division sign to a multiplication sign, and you flip your last fraction to get the reciprocal, which will be 3/2 instead of 2/3. You see, I've flipped those numbers around. So it's keep, change, flip. I kept my quarter, I changed my division to multiplication, and I flipped my last fraction to 3/2. Then once you've done that, you can see you've just got a normal multiplication of 2 fractions. So I multiply 1 and 3 together, that gives me 3. And I multiply 4 and 2 together, that gives me 8. So my answer is 3/8. So that was 9A. 9B, same thing, we've got 4/5 divided by 1/10. Keep the first fraction, change the sign, flip the last fraction. Then multiply as normal. 4 times 10 is 40. 5 times 1 is 5, okay? Some of you may have noticed, then you can simplify 40 divided by 5, that means is 8. And 8 is your final answer. Okay, but don't worry if you didn't get as far as that. Question 10. Question 10a says, work out 6 over 0.3. So that means 6 divided by 0.3. Okay? So 6 over 0.3. So how many 0.3s will go into 6? So that's the same as 6 divided by 0.3, which is equal to 3/10. Okay? 0.3 is 3/10. So then 6 divided by 3/10 essentially. Now 6, I want to make that a fraction to make it easier for myself now, so I can apply the rule as normal. 6 as a fraction is just 6 over 1, because it's 6 divided by 1 would get me 6. So 6 over 1 divided by 3/10 is now what we're doing. We know the rule when we're dividing fractions: keep, change, flip, then multiply as normal. 6 multiplied by 10 is 60. 1 multiplied by 3 is 3. And now I'm going to simplify. How many 3's go into 60? 20. And that's my final answer. Okay? 10b. We have 1 over 0.04, which is the same as 1 divided by 400. 4 over 100 is equivalent to 0.04. My rules: 1 over 1 is changing 1 into a fraction, divided by 4 over 100. So keep the first fraction, change the sign, flip the last fraction, multiply as normal. 1 multiplied by 100 is 100. 1 multiplied by 4 is 4. Then you say, can I simplify? Well, yes, because 100 divided by 4 is 25. 25 fours go into 100. And you're done. Okay, question 11. Well done if you did remember how to do this, okay? So it wants us to write these products using powers, okay? So write these products using powers. 4 multiplied by 4 multiplied by 4 is equal to 4 to the power of 3, okay? So I'm multiplying 4 by itself 3 times. So it's 4 to the power of 3, 4 cubed. Okay, B, we've got 9 times 9 times 9 times 9 times 9 times 9. There are 6 9s, so we're timesing 9 by itself 6 times, so it's 9 to the power of 6. As easy as that when you know what it means by saying write these as products using their powers. Okay, 12a, it wants to know 2 to the power of 4, which is 2 times by itself 4 times, and the answer there is 16. B wants to know 5 cubed, so that means 5 times by itself 3 times, and that would give you 125. And C wants to know 8 squared, and hopefully you knew that without working anything out. That's 64. Okay? Question 13, I would be surprised if anybody was able to do them, and impressed, well done if you could. But these are now bringing in your laws of indices, so don't worry if you didn't know what to do here. I'll talk you through it briefly, but we're going to be covering it in this unit, okay? So 13a was 3 squared multiplied by 3 cubed. Okay, they want it as a single power, your answer. The rule here, when you multiply, you add your indices. So it's 3 to the power of 5 would be my answer, because 2 plus 3 is 5. B, You've got 5 squared multiplied by 5 squared. Same thing, you add your indices. So you get 5 to the power of 4 because 2 plus 2 is 4. With C, we're dividing our indices here. So we've got 6 to the power of 7 over 6 to the power of 2. So we subtract. The law when you divide is that you subtract. 7 subtract 2 is 5, so my answer is 6 to the power of 5. And D is the same, it's a division, but it's just written in a different format. 8 to the power of 11 divided by 8 to the power of 3. We're dividing, so we're going to subtract our indices. 11 subtract 3 is 8, so that's going to be 8 to the power of 8. Okay? And there are your answers there. We had a challenge, but I'm going to leave the challenge, okay, because it's not very relevant. Don't worry about the challenge part. I should have said that at the start. But well done if you got up to here. Again, I would not expect many of you to have done that, so don't worry at all if you haven't, okay? We're going to go through all of this. It's just to test where you are so far before we go through the knowledge, okay? So well done. Okay. So we're going to start by considering what the reciprocal is, okay? Just wait for my screen to load. So sometimes you'll be asked to find the reciprocal of a number or the reciprocal of a fraction, etc. And you need to know what to do there. So to get the reciprocal of a number, we simply divide 1 by the number. So for example, if I wanted to find the reciprocal of 8, let me go back to my split screen. So I'm finding the reciprocal of 8. That's what it wants me to do. So the reciprocal of 8 is, it says, to get the reciprocal, we simply divide 1 by that number. So 1, and you divide it by the number. That's 8. The reciprocal of 8 is 1/8. Okay, so we're essentially turning the number upside down. So for example, to understand that, if we wanted to find the reciprocal of 5, they're saying we essentially turn the number upside down. Well, I know that 5 is the same as 5 over 1. Okay, we don't write that because we simplify it to 5, but 5 is 5 divided by 1 because that's 5. So we're simply flipping it to find the reciprocal. So the reciprocal of 5 over 1, so 5 is going to be 1 over 5, 1/5. Okay? If I wanted the reciprocal of 3, it's going to be 1/3. Okay? Because 3 is equal to 3 over 1. And if I flip that, it's going to be 1/3. Okay? That's its reciprocal. It's not equal to. I shouldn't write that. It's the reciprocal. Okay? So let's have a look. I'm going to show you some examples. So for example, it wants me to find the reciprocal of 3/4. Okay, this is a slightly different example now, but I'm simply going to flip it. To find my reciprocal, just flip your fraction. If it's just a fraction, flip it. So it's 4/3. The reciprocal of 3/4 is 4/3 because I've flipped it. Similar to what we were doing when we were dividing. The second one, it says it's keep, change, flip. When you're flipping, you're actually getting the reciprocal of that fraction or number. Okay? So there's 5 there that I'm going to do for you. What I'd like you to do is watch carefully and consider what I'm doing, and then you're going to have some to try for yourself. So for question 1, I want to find the reciprocal of 5/7. Okay, it's a fraction, so all I have to do is flip it. So the reciprocal is 7/5. I've turned it upside down there. Okay. Question 2 is I've got 7. I want to find the reciprocal of 7. Remember that 7 is equal to 7 over 1. We don't write that because it's simplified as 7, but it's 7 divided by 1, which is 7. So that's my first step. I'm going to write it as 7 over 1. Then I simply just flip it. 1/7. So the reciprocal of 7 is 1/7. 1 over that whole number. 3, I've got 1/9. To find the reciprocal, just flip it. 9 over 1. 9 over 1 is 9. Number 4 is more involved now, so watch carefully. Number 4. I've got 2 and 3/4. Before I'm going to find the reciprocal, I am going to convert this mixed number to an improper fraction. Remember, an improper fraction means I'm going to make my numerator bigger than my denominator and get rid of my integer there, my whole number. So 2 multiplied by 4 is 8. 8 plus 3 is 11. And then my denominator stays the same. So that is equal to 11 over 4. Now I can find my reciprocal easily because I just flip. So the reciprocal of 11/4 is 4 over 11. Okay, so the reciprocal of 2 and 3/4 is 4/11. You must do this step first. You must convert it to an improper fraction first. Question 5, let's do it again. We've got 1 and 5/6. My first step, I'm going to convert it to an improper fraction. I convert to an improper fraction by number 1, multiplying my whole number by my denominator. 1 times 6 is 6, and add that to your numerator, your top number. So 6 add 5 is 11. Okay, so 1 multiplied by 6 is 6, add 5 is 11, and my denominator stays the same. Okay, so that's equal to 11/6. Now I can find my reciprocal. I just flip it. So my reciprocal is 6/11. Okay? So rewatch that if you need to. Otherwise, you've got some here to try for yourself. I'm going to put that on the full screen for you. Pause the video. Play when you're ready to go through the solutions. And make sure you're careful of the mixed numbers you've been given there. Okay, so number 6 is a mixed number. So remember, you need to convert to an improper fraction first. Okay, so pause and please play when you're ready to go through the solutions. Okay, so let's go through the solutions. We want to find the reciprocal of each fraction or mixed number there. Okay, so question 1, we have 4/9. 4/9, the reciprocal of 4/9, flip it, 9 over 4, 9/4. Okay, question 2, the reciprocal of 5. Okay, hopefully you know straight away it's 1/5. If not, you might have done the extra step saying, well, 5 is equal to 5 over 1. And if I flip 5 over 1 to find the reciprocal, it's going to be 1/5. Question 3, we have 2/5. Flip it, the reciprocal is 5 over 2. Number 4, we've got 1/7. Flip it to find the reciprocal. That gives us 7 over 1, which is equal to 7. So my reciprocal there is 7. Number 5, we've got 11. So that's equal to 11 over 1 if you did it that way. So my reciprocal is 1/11, 1 over 11. Number 6, okay, pay close attention. We've got 1 and 2/3. I need to convert it to improper first. 1 multiplied by 3 is 3. Add 2 is 5, so it's 5/3 as an improper fraction. The reciprocal of 5/3 is 3/5. Okay, number 7. We had 4/11. The reciprocal therefore is 11/4. Number 8. We've got 1/4. The reciprocal is 4 1s, so that is 4. And number 9, the final one, we have 1/20. So flip it to find your reciprocal is 20 over 1, which is 20. So well done if you got those. Okay, so now it's got a little bit more tricky. It's not tricky, you just have to convert it first before you can find the reciprocal, okay? So here we're looking at decimal numbers and they want to find the reciprocal. So in order to do that, before we can get to the reciprocal, we need to convert those decimal numbers to fractions, okay? So I will demonstrate how to do that on the visualizer. So Let's just move this over. We need to find the reciprocal of decimal numbers. So the first thing I need to do is to convert from a decimal to a fraction. So 0.5 as a fraction, I hope you know, is a half. 0.5 is a half. That's one of the conversions you should know. Okay? Now I can flip it as normal. I'm finding the reciprocal of a half. Well, the reciprocal, the opposite, flipping 1 over 2 is 2 over 1, which is equal to 2. So that's my reciprocal done. Okay? I've converted it to a fraction, then flipped it as normal. Question 2. We need to know what 0.06 is as a fraction. Okay? So I'm going to remind you of your place value table. Okay? So this is my decimal. Ones, tens, hundreds, etc. And going down, we're going to have tenths, hundredths, thousandths, etc. Okay? So if I fill in my place value table with my decimal, so that's where my decimal goes. So it's 0 1, 0 ones, 0.0 tenths, and 6 hundredths. So 0.06 gives me 6 hundredths. If you look at the number, you look at the column in which the number ends, it's in the hundredths column, and there are 6 hundredths. Okay, so that is equal to 6 over 100. Okay, and flip it, 100 over 6. Okay, and 100 divided by 6 is not divisible. You could simplify if you wanted to, but it hasn't asked you, okay? But it doesn't simplify to a whole number. So you can just leave your answer as that. Okay, number 3, we've got 0.86. Okay, if I were to put that in my table, 0.86, what column does the number end? It ends in the hundredths column, so I have 86 hundredths. Okay, 86 over 100 is what that is as a fraction. To find my reciprocal, I need to flip it, 100 over 86. Again, you could simplify, but it hasn't asked me to here, so I'm just going to leave it like that for now. Okay, number 4, we've got 0.405. I need that as a fraction first. So if I put it here, 0.405. What column does it end in? It ends in the thousandths column. So I have 405 over 1,000. Okay, find the reciprocal. It's going to be 1,000 over 405. You shouldn't get any of this complicated. This is just so you understand the practice. Okay, and then finally, number 5, we've got 3.5. Okay, you know that that's 3.5, but I can't find the reciprocal of 3.5 like that. I need to convert it first into an improper fraction. So that's equal to 3 times 2, which is 6, add 1, which is 7. So it's equal to 7 over 2. Then find your reciprocal by flipping. It's 2/7. Okay, and that's your final answer. Okay, so you have the chance to have a go there. Let me just put that on the full screen. Pause the video and play when you're ready to go through the solutions. Okay, they're exactly like the ones I've just done. So refer back to me going through those if you need to. Okay, so if we're going to have to look at the solutions at your turn, I'm going to keep my place value table up there so I can help you as we're going through. So question 1, you had 0.7. I hope everyone knew that that was just 7/10. If not, you put it in your table. My number ends in the tenths column, and I have 7 of them, so I have 7/10. Okay, 7/10 is what 0.7 is as a fraction. To find the reciprocal, I just flip, so it's 10 over 7. Question 2, 0.09. If I put that in my table, 0.09, it ends in the hundredths column. I have 9 hundredths. Find the reciprocal by flipping. It's 100 over 9. Okay? 3, you've got 0.45. If I put 0.45 into my place value table, my number ends in my hundredth column and I've got 45 of them. So it's 45 over 100 as a fraction. And if I flip that, it's 100 over 45 is the reciprocal. Okay, and like I said, you don't need to simplify for these examples. Question 4, we've got 0.705. Put that into your place value column, 0.705. That ends in the thousandths column. I've got 705 thousandths, therefore. Okay, find the reciprocal, flip it, 1,000 over 705. You can simplify it, but again, you don't need to for this question. The last one, question 5, you had 5.5. Okay, so hopefully you knew that that's 5 and a half. And remember, we need to convert it from a mixed number to an improper fraction first. So 5 times 2 is 10, add 1 is 11, so that's equivalent to 11 halves, 11 over 2. Okay, now find your reciprocal, flip it, it's 2 elevenths. Okay, so well done if you got those. Okay, we're now going to have a look at multiplying fractions, okay, and then we'll stop at the end of this practice session. So once we've had a small practice of multiplying, we will leave the lesson there and we'll pick up ready for the next lesson that you'll have, okay, where we'll be dividing fractions. So the two examples that I have, or one example, sorry, then it's your turn. I've got 2/3 multiplied by 1/6, okay? Multiplying fractions is really easy. All you need to know to do is multiply, okay? 2 times 1 is 2. Multiply your two top numbers together, they're called your numerators. 2 times 1 is 2, so that's the top number, your numerator in your answer. 3 times 6 is 18, so that is your denominator. Okay, 3 times 6 is 18. You can simplify this, they're both divisible by 2 because they're both even, so you can have 1/9. Okay, please pause the video and have a go at the other example that's there. So 2/3 multiplied by 5/6. Pause and play when you're ready to have a go to check if you understood the solution. Okay, so for your turn you had 2/3 multiplied by 5/6. You need to do 2 multiplied by 5 because we're multiplying our numerators together. 2 5s are 10. And then 3 multiplied by 6, which is 18. So your answer is 10/18. That's not been simplified. They're both divisible by 2. 10 divided by 2 is 5. 18 divided by 2 is 9. So you could have had 5/9. Okay, but don't worry if you didn't simplify and you only got to that part. That's fine. Okay. So please now have a go at the questions that are on the screen. Pause and play when you're ready to go through the solutions. Okay, I'm only going to go through one or two with you, and then I'm just going to put the answers on the screen, okay, because I hope that this isn't too tricky for you. Okay, so I'll go through the first two there. The first one is 2/3 multiplied by 1/10. Multiply your numerators. 2 times 1 is 2. Then multiply your denominators. 3 times 10 is 30. I can simplify that, but don't worry if you didn't. 2 and 30 are both divisible by 2 because they're both even. 2 divided by 2 is 1, and 30 divided by 2 is 15. So 1/15 is the final answer there. Then I'll do the 4/3 multiplied by 2 over 2. I wonder if you spotted anything there. Let's just do it first and then I'll explain. So 4 multiplied by 2 is 8. 3 multiplied by 2 is 6. They're both even. They're both divisible by 2. So 8 divided by 2 is 4. 6 divided by 2 is 3. So my answer is 4/3. Now, that's fine if you did it that way, but hopefully you recognise that 2 over 2 is 1. So actually what you were doing there was 4/3 multiplied by 1. And we know anything multiplied by 1 is just whatever it was in the first place. So it's 4/3. Okay, don't worry if you didn't spot that. It doesn't matter as long as you did the process correctly. But that would have been a quicker way to get to your answer. Okay, so there are the rest of the answers there on the screen for you. Please check them, correct any that you didn't get right, and then we will move on. Okay, so now what we're looking at in my examples here is multiplying with mixed numbers. Okay, multiplying fractions where we've got mixed numbers involved. And it's the same as like what we were doing before when we were finding the reciprocal. Before we can actually do anything, we need to convert the mixed number to an improper fraction. So my example is 1 1/3 multiplied by 2/5. Okay, and like I said, before I can do that, I need to convert this mixed number here into an improper fraction. And to convert that to an improper fraction, I do 1 multiplied by 3, which is 3, and I add 1, which is 4. So that is equal to 4/3 multiplied by 2/5. And now that I've done that, I can now multiply as normal my fractions. Okay, so 4 times 2 is 8, 3 times 5 is 15. Okay, and my answer is 8/15. Okay, pause the video please, have a go at the your turn, and then I'll go through it when you play the video and you can check through your solution. Okay, so for the your term, you were asked to calculate 1/3 multiplied by 1 2/5. Okay, and hopefully you remembered you can't do that without converting this mixed number to an improper fraction first. So your 1/3 will stay the same, and you're going to multiply it by, well, let's convert it. 1 times by 5 is 5, plus 2 is 7. So you're multiplying it by 7/5. Now you can do that easily. Now it's converted. 1 times 7 is 7. 3 times 5 is 15. So your answer there is 7/15. Well done if you got that. Okay, on the screen now are a selection of questions for you to try. Please pause the video and play when you're ready to go through the solutions. Okay, I'm going to put the solutions on the screen for you so you can check your work, and then I'm going to go through 2 of the questions there just for extra practice. And then the rest I'm going to leave for you to check, okay? So for the first one, we had 1 1/2 multiplied by 1/4. Okay, this is question 1 there. So the first step, you need to get rid of your mixed numbers and you need to convert them to improper fractions first. So 1 times 2 is 2, add 1 is 3. So that is equal to 3/2 as an improper fraction. Okay, and then I'm just multiplying it by 1/4 as normal. 3 times 1 is 3. 2 times 4 is 8. That's my final answer, 3/8. If I try the next one going along across the top, don't worry if you went down, doesn't make a difference as long as you've practiced them all. We had 2 1/3 multiplied by 4/5. First step, get rid of my mixed numbers there, make it an improper fraction. 2 times 3 is 6, add 1 is 7. So we've got 7/3 multiplied by 4/5. Now we just need to do our multiplication. 7 times 4 is 28. 3 times 5 is 15. Okay, So you could have left that as an improper fraction as 28/15ths, or like they did, they then converted it to a mixed number. How many 15s go into 28? Well, that's 1. That becomes my integer. And then how many remaining? 13. So that's my numerator now. Okay, but don't worry if you did that. I just want to know if you could get to this stage at the moment. Okay? Then please mark the rest of your answers. And then that's the end of our session today. The next session will continue with dividing fractions, and then we will be continuing on, okay? So well done if you got that today.